All right, guys, welcome back for part 3. We're going to tackle question 4. I saved the hardest one for last. The other two, I guess you can think about as more warm-ups, and this is going to be our challenge problem. So, with that being said, let's try and tackle this together. By the way, I went ahead and did all of the Laplace transform already and solved for my x of s. I think we should be good on that already by now. So, as you can see, I had to write out a little bit of notes for myself in this bottom corner, right? Just want to make sure that we're following all the steps correctly. And so I just wanted to get straight to what happens when the quadratic in the denominator is not factorable, right? 34 does not have any factors that can add up to 6, right? So now we've run into a problem. We're like, oh, okay, what are we going to do? Well, the first step here is going to be complete the square, okay? So we're going to look at this and we're going to say s squared plus 6x plus 34, right? Actually, when you complete the square, you want to move over that 34, right? But in this case, we'll do it this way for now, right? We'll just set it equal to 0 and move over the 34. We'll add a blank here. And the formula for completing the square, again, call back to algebra 2 if you guys remember high school. 6 divided by 2, right? And we're going to square it. So the formula is b divided by 2 squared. And that is what c is equal to for completing the square, right? Completing the square. So we're going to get 3 squared, which is 9. So that puts a 9 in there. Okay. Now when we factor this, right, it's going to be s plus 3 squared. Okay. And we're going to add in 34. However, because, right, we would add 9 to both sides, right, this would actually be minus 34 plus 9, which is 25. Yeah, 25. All right, so plus 25. Okay. So we successfully completed the square. I'll go ahead and write that here. I'll just rewrite it. Because now our second step is going to be partial fraction decomposition. Okay. So let's go ahead and do that for the this is going to be the forced response, right? Because we can see the 68 unit step function is our input. So forced response side. And we'll save the right side for later. The right side is where things get a little bit more complicated. So partial fraction decomposition, we're going to use a form that we actually haven't used before. It's going to be a over s plus bs plus c, okay, with s plus 3 squared plus 25 on the bottom. Okay, so first step, it's going to be a times our original polynomial, right? Because that's all s plus 3 squared plus 25 is. It's just the original polynomial. So it's going to be as squared plus 6as plus 34 and 34a. And if you really don't believe me, you can go ahead and FOIL that out again, right? And go through the whole step process. But you're going to get s squared plus 6x plus 34, right? Okay, so next is going to be the bs plus c. That's going to be bs plus c times s, right? Think about it as like cross multiplication. So bs squared, and there's no other terms for b, and cs. So cs would go here, and there's no other terms for c. Okay, so this is our matrices setup, and so to speak, informal matrices setup, right? And so a plus b, as we can see, the s squareds, they're going to equal 0 because we have no s squared term. The 6a plus cs, right? 6as plus cs, that's going to get us also equal to 0 because there's no s term in our numerator. And 34a is equal to 68. So luckily, 8a equals 2. A nice, clean, even number for us. Okay. That means that b must equal negative 2. Right? We're using this equation. Okay, and then 12 plus c is equal to 0, right? I plugged in a for that, 2 for a, so c is equal to negative 12. Okay. So now let's go ahead and put that form in 1 over s. Okay. And then bs plus c, so that would be negative 2s minus 12. Okay, so plus negative 2s minus 12 all over s plus 3 squared plus 25. Okay. So this is our forced response. I'll go ahead and hold off doing the Laplace transform on that. We'll go and try and tackle the right side. So the right side, right, we're actually not going to do partial fraction decomposition. And if you notice, it won't really work because the form that we would use for this partial fraction decomposition would just be as plus b, right? But then a would just equal 5 and b would just equal 37. But that doesn't really help us. We're going to come into a roadblock. So there's actually a different technique we're going to have to use, and that's what makes this problem a little bit tricky. Okay, so you notice, right, I wrote these two additional forms, right, previous to the last part. And these are just going to be used to basically simplify this portion so that we can then take the inverse Laplace of that. Okay, so rewriting it below, I'll rewrite it. Let me just copy paste. Okay. So let's see. How can we make this look more similar to this? This might take a little bit of thinking. I'll go ahead and do the bottom portion. So as we can see, a would be equal to -3, right? And b would be equal to 5. So we can grasp that. So this is going to be important. We want to make the top. So I think I'm going to split these up. I think I'm going to split it up into 5s, right? Over its bottom plus 37 over its bottom. And the form b. So we want b to look like 5. So this one would probably be b. So how do we make 37 look like 5? Well, that means that we'd have to multiply by 5 37ths, right? 37 with that. Let me check my work. I did the solution for this off screen just because this one's really complicated and I wanted to be able to explain it in a way that didn't confuse anybody. And so our first step, right, is to look at this 5s plus 37. And we know we want something in the form of s minus a, right? And so we say to ourselves, okay, well, we know a is 3. I should go and highlight this. Very important numbers to keep track of, a and b. Okay, so we know a is 3. So we want something in the form of s, in this case, s plus 3, right? Plus just because we already have a plus. So why mess with the signs? Why make life more complicated for ourselves, right? So I find it best to start with what we want and then manipulate the expression to keep everything balanced and equal. So I put s plus 3 first, okay? And then I say, okay, well, there was a 5 in front of that s, so I have to have a 5 there, right? Okay, so it makes sense. I need a 5 here. But then I say, okay, when I distribute this 5 into both of these terms, I'm going to get 5 times 3. That'll get me a 15. Right? Sorry, let me show that screen a little better. That'll get me 15. Okay, so I need something to get rid of that 15. Because as you can see, I essentially split my equation. Right? I split my equation. And so the 37 is off over here. Right? So the 15 needs something to cancel out with. And so I add this completely new term right here. This -5 times 3. Right? Because that'll get me a -15. Okay. And the reason why that doesn't affect anything is because now I can combine these two terms into one term. Right? That gets me 22 over my denominator, right? Same denominator. Just saving time by not writing it. And so now, okay, let's go ahead and do inverse Laplace on this, since we can. We'll do the inverse Laplace on this one. So the inverse Laplace would be 5, right? And then s minus a. So a is -3. Okay, so it'll be e to the -3t. And then cosine b is, as we discussed, sorry, this should actually be in its completed the square form, right? S plus 3 squared plus 25. Right, so b is 5, means that this would be 5t. So as we can see here, I got this solution, by the way. I had to check using Matlab, just like how I showed in part 2, and I'll go ahead and re-verify that just so that you guys can see. Right, so this matches up with the cosine portion. Okay. Next, we're going to look at this part, right? The constant b. Right, so how do we get b on top? Because right now we're stuck with 22, right? So how do I get it to look like this 5? Well, you can think about it as I slide this 22 out, right? And I multiply top and bottom by 5. Right, that inserts my 5 into the top, and this 5 in the denominator, right, keeps everything balanced. Right, this is the same equation because I can just cancel out those 5s at any time. And so now this will take the form of, right, pretty simple, e to the negative 3t. Right, this constant goes in front, so 22 over 5, and then this time it's sine of 5t. Okay, so that corresponds to this portion, right? And this is our, this is our free response. Okay, this is our free response portion. The other portion that we solved for, oh, we didn't do the inverse Laplace yet, the other one. So let's go ahead and do that. So forgot to do that. Sorry, so many moving parts. Lots of stuff going on. So see, this one will just be 2. One's easy, it's a constant, right? 1 over s just goes to constant when you do inverse Laplace. I want to factor this out on the top. I get s plus 6, s plus 3 squared plus 25. Ooh, okay, I think we're going to get the same problem again. So we're going to have to split this as s plus 3, s plus 3, right, and then this would be a negative 2 in front. Okay, and then that would be the denominator. Okay, and then that would cause a negative 6. So we need another negative 6 or positive 6, right, to cancel that out. So it would be a positive 2, 3 over that. And then subtract 12. So subtract 12. So this one would be negative 2, and that relates to the cosine form, right? So when we have s plus 3, that relates to the cosine form. So it would be negative 2 e to the negative 3t cosine of 5t. Okay. So now that's the inverse being done. Let's see. This one we would get negative 6 over here, but we want 5. We want 5, so we should do the same trick we just did. Slide the negative 6 out, put in a 5, and to keep it the same, we want to insert a 5 on this side as well. And so now this will take the form when we do the inverse Laplace. It'll be negative 6 over 5 e to the negative 3t sine 5t, right? Okay. So the forced response portion will be 2 plus, this is a minus 2e to the negative 3t cosine of 5t, and minus 6/5 e to the negative 3t sine of 5t. Let me just go ahead and verify that that is correct with Matlab. And yes, indeed, we did everything correctly. Okay, nice. And so now, right, let me just make this look a little bit prettier. I'll just move that out of the way, and let's go ahead and box this off so we can see clearly that this is our forced response, right? So I kept them separate and I solved for them separately. So now I can go ahead and combine them into our complete response. Right, so I'm going to look for the similar terms. I'm going to see that we have a e negative 3t cosine 5t, e negative 3t cosine 5t, and our sine t's are here, and then the constant, right, is by itself. So looks like we're going to do 5 minus 2 gets you 3e to the negative 3t cosine of 5t. And 22 over 5 minus 6 over 5. That should be 16. Right, so plus 16 over 5 e to the negative 3t sine of 5t. Okay, and then plus 2. Let's use. Okay. That is our complete response. And now we're back in Matlab. So you can see that this over here, this first equation on the top, that is going to be our free response, right? The 5s plus 37. And as you can see, this is the verified solution. Now all you have to do is distribute this exponential into these two terms, as well as the 5, right? Don't forget to distribute the 5. I don't know why Matlab likes to put these constant terms on the other side of the parentheses. I'm not really sure, just a preference, I guess. This is the forced response right here. So this one is the forced response, 68, right? Yeah, again, you can go ahead, distribute to verify your solution. And this is the complete response. So all I did was go ahead and, make these same denominator, right? And combine the tops. So you can see that where they come from, the 5s, right? 5s squared plus 37 plus 68. You can just see that I combined the numerators and made the denominators even. So I made it all into one fraction. And then I did the inverse Laplace on this entire, right, fraction, which couples the free and forced responses together. And if there is any type of content or specific topics that you want to see covered on this channel, please feel free to leave a comment below.